And I hope that a great many of you follow the little shortcut to do this, whereby you go x squared plus 10x plus 24. Right? Right? And then, of course, if I ask you to factor that, you've already got the answers right there, but you know you need to multiply to 24 and add to 10. Right? Cool? That's what we've already done, yeah? Okay. Now, please expand this. Now, most of you are probably going to need to do FOIL there. That's okay. I expect you to. 6x squared minus 4x plus 3x minus 2. Yeah? And then you're going to add up your like terms to get 6x squared minus x minus 2. Is everybody cool with that? Everybody can do expansion, yeah? I skipped the quiz on it because we had the time off. Everyone's all right? Okay. Now, I want you to look at that expanded trinomial and that expanded trinomial and tell me what is similar. Not what's different. Tell me what's similar. Normally I ask for the differences. Today I do not want differences. I want what's the same. There is a squared term. That is one thing that is the same. There is a squared term. Excellent. What else? There is a single x term. Excellent. Remember, we call that the linear term. They both have a linear term. Does anybody remember the proper term for the first one? I don't expect you to. I only said it once. It's the quadratic term. That will be important to you next year, not so much now. What else is the same? It's got a constant. Okay. So now, you all agree that there are three things that are exactly the same between those two trinomials, yes? And what is the difference? What? I'm sorry, Brahman? There are different signs, absolutely. What else? Tiffany? There's a leading coefficient. Anything else? Okay. So, we already know from our previous factoring experience that the signs don't mean a lot, do they? We can always work our way around the signs. So the only real difference here is that coefficient and that coefficient, yes? If I write this, do they now look exactly the same? Does everyone agree? I mean, they're different numbers, but they have all the same components, yes? Okay. Now, to do this question, to factor it, I needed to do this, yeah? Now, consider this. There's three similarities and one difference. If you were to attempt to factor this by yourself, if you were to attempt it, what would you do if I gave you this question, 6x squared minus x minus 2, and I said factor it? You already know this is going to be the right answer, right? So using what you see there and what you see here, can you figure out a way that you could get these factors? What do you see in those factors that relates to over here?
2 and 3 multiplied 6.
You see that 2 and 3 will make 6, yes? What else do you see?
1 and negative 2 equals negative 1.
That 1 and negative 2 multiply together to make negative 2. And what else do you see?
They add together.
1 and negative 2 add together to make that. Do you all see that? Now, we have already seen this construction, haven't we? Right here. Multiply to 24, add to 10, yes? And here you see it again. Multiply to the last number and add to the middle number. So doesn't it stand to reason that we would use that again when we are factoring something that looks slightly different? Since you can plainly see that it works again in some way. Is everybody with me? Does everyone see what I'm talking about? Right? We all see that 4 and 6 made 10. 4 times 6 was 24. 1 and negative 2 makes negative 1. 1 times negative 2 makes negative 2. Is everybody cool with that? Okay. So what I'm going to do is I'm going to show you 3 ways to do this. One is the way I was taught. It works. There's about maximum of 5 kids every class that is like, oh my God, I get it. That's the way I want to do this. The other 20, they can't see it to save their lives. Okay? So I'm going to show you that last. I'm going to show you the other 2 ways first. Okay? The first way that I like to do it is a way I discovered when I was trying to teach this like 15 years ago. It comes from Australia, believe it or not. Some Australian math teacher figured it out. And it's stupid because I don't know why it took so long to get. So the first one I'm going to do, and we're going to work it in red. I'm going to erase this. So I'm going to work this in red. So step 1, you take... Remember, this is A, B, and C. Right? That's the A term, the B term, the C term. Step 1 is you do A times C. So what is A times C here? What's A? 6. Just the number. And what's C?
2.
Negative 2. And that equals negative 12. Now, you do the exact same thing you already know what to do. You need to multiply to negative 12 and add to negative 1. What is it? Somebody whispered something over there. Turn out more lights if you need to. What is it? 4 and 3, yes? Everyone agrees? It is 4 and 3, correct? Which one? Positive 4 or positive 3? Negative 4 and positive 3, right? So if this 6 wasn't here, it would be x plus 3 and x minus 4, correct? Please write it this way with a big space there. Is everybody okay with what I have just done?
Yeah.
Now look back here. That's no different than here, right? Because if I did 1 times 24, I would be looking to multiply to 24 and add to 10, right? You've already seen this, right? Now, I have this set up, but I am trying to factor, aren't I? What is the math operation required to factor? Division. Have I done any division yet? No. I'm trying to get rid of this 6, aren't I? Right? All I've done with that 6 is multiply it through. What would get rid of it? What gets rid of multiplying? Divide. So now if I divide by 6, everybody cool? Is everybody okay with that? Does everybody see why I'm doing it? I'm trying to get rid of that 6. So I'm dividing by 6. Is everybody good? And I'm not dividing the x by 6 because I don't know how big x is. Do I?
No.
Okay. If you were in grade 3, would you ever leave that fraction? What would you turn that into? 1/2. If you were in grade 3, would you ever leave that fraction? What would you turn it into? 2/3. Is everybody cool with that? Everybody good? Now, don't write down what I'm about to write down. Just watch. Ah! Could we expand that?
Yes.
What would we get? X squared minus 2/3 x, yes? Plus 1/2 x minus 2/6. Correct? Everybody with me? Yeah? Okay. And 2/3 and 1/2. Can I add them together, or do I got to do some funky math with that? I got to do a common denominator, don't I? So that's x squared. That's going to be 4/6, negative 4/6 plus 3/6. Yes?
Yep.
What is negative 4 plus 3?
1.
Negative 1/6 x. Yes?
Yeah.
Minus 2/6. Does everyone agree? Does that look like a trinomial that we are happy with? What about that trinomial makes us go, ugh? Fractions. How do I get rid of divided by 6? Multiply by 6. What's 6 times x squared? 6x squared. What happens to these 6's? Cancel, leave me with negative x. What happens to these 6's? Cancel, leaves me with negative 2. Good gravy. Does everybody see what happened there? Now, so right now we have this ugly mess, don't we? Right? I'm going to go ahead and erase before the simplification. I'm going to erase where we started. Is everybody okay with that? Because that's what we drew on the next page. I told you not to write. Is everybody cool with that?
Yeah.
Now, what don't we like about this binomial? I don't like that there's a divide by 2, so what do? How do I get rid of that divided by 2? Multiply by 2, right? So that would cancel out that 2, and it would make this x what?
2x.
2x plus 1. Please notice that the shortcut is just moving to the front. What do I get here? What would I have to multiply here?
3.
3. So the 3 would move to the front. Does everybody see what I did there? The math is complex, isn't it? But the steps, if you just want to memorize steps, it's not bad, is it? It's all steps you already know with one extra thing. Make a fraction, simplify it, pull the denominator to the front. Is everybody good with that? We'll practice it a bunch, don't worry. Are you on the beginning of okay with it? All right, that is way 1. I find that to be the easiest way to do it if you want to just learn, okay, I'm looking at a trinomial, it's got a leading coefficient, I can't GCF it, I'm going to follow this path. If that's the way you do math, that's the method for you. Got it? There's another way. And this was taught to me by some Asian exchange students a few years ago. Because I was teaching this, so like, Mr. Myers, there's an easier way to do that. I was like, oh, really? What do you do? And they do this. They look at this term and this term. And they want factors of that and factors of that. And it's really trial and error. Okay? So they look at 6 and they go, okay, 6 can be 6 and 1, and 2 can be 2 and 1. Everybody with me? And then they look at it this way, 3 and 2, and 2 and 1. Because those are the only options, yes? And then they check, they do a cross. They go 3 times 1 and 2 times 2. 3 times 1 is 3, 2 times 2 is 4. Can 3 and 4 make 1 in any way? Yeah.
Yeah.
So this is the way that works. Do you understand? So then they have to decide 3 times 1 gets me what? 3. 2 times 2 gets me what?
4.
4. How do I get 4 and 3 to make negative 1? There has to be a minus somewhere, yeah? Where?
3.
It'd have to be here, right? 2 times negative 2 to get negative 4. Everybody with me? And once they have this box set up, then you just go straight across. 3x minus 2. And down here, 2x plus 1. I don't like that, personally, but a lot of kids do. Because they like to do trial and error. It's totally up to you. I don't care which way you use. Now, I'm also going to show you a third way. This is the way I learned how to do this. And there's always a couple of kids in the class that like this third way best. And I'm going to do that one in green. So you have 6x squared minus x minus 2. Yeah? Everybody cool? Okay. Now, what you do with this one is you say, all right, I got to see if I can remember how to do this because I haven't done this since the 11th grade. It starts out the same. You do 6 times 2 to get negative 12. That's step 1. Step 2 is you decide on your factors. So we already know that it's 3 and 4, right? Positive 3 minus 4. That's step 1. That's step 2. And you write it as 6x squared plus 3x minus 4x minus 2. Do you all see how it's the same thing? 3 minus 4 gets me negative 1, yeah? Then you factor this and you factor this. What's the common factor here? 3x, right? And what does that leave you with? 2x plus 1. Cool? Everybody okay there? Then you do the same thing here. What's the common factor here? Negative 2, right? Negative 2. And that leaves you with 2x plus 1. Now, you guys have already seen this, right? Common factor is 2x plus 1. So it's 3x minus 2 times 2x plus 1. And you notice you get all the same answer. I don't care which way you do it. I'm going to use all 3 until I get a majority from you guys. Do you understand what I'm saying? You use what you're comfortable with. I don't care which one you use. I only want to give you as many tools as I can give you to solve the problem. Okay? Most of the time, and I'm not trying to influence you in any way, very few kids like the Greenway. But I've noticed in the last few years that if a kid doesn't understand either the red or the blue way, I'll show them the Greenway and they're like, oh my God, that makes perfect sense. I don't really understand it because they're all the same thing, aren't they? It all requires you to multiply it. Like, they're all the same thing. But I've had kids fight with me like, I don't get it. Maybe I could show you this. Oh, I get it now. And I'm just like, good. And then they leave, and then I take a pen and I shove it into my eye. Because it's the exact same thing, isn't it? Mm-hmm. Is everybody cool? Mm-hmm. I don't care what way you use. This is what I grew up with when I was your age. This is what the kid from Hong Kong taught me. This is what some math teacher in Australia taught me. Where did I find that? The internet. Because I got tired of teaching kids this and having them, I don't get it. So When you can't solve the answer to a problem, you go to the place where every problem in the world has ever been solved, the internet. And you don't get trapped by, you won't believe what Miley Cyrus did on the weekend. You don't click on that link. Okay? Now, is everyone all right with this? Is everyone okay? Obviously, you need to practice. You're not just going to be, oh yeah, I got this. We'll practice right now. I don't want to do number one yet, because number one's really hard, and I'm looking out at you and I'm seeing some stressed faces. So we'll start with number two, that's easier. No matter what method you choose, you know you're going to be dealing with stuff that multiplies to 3 and stuff that multiplies to 10, right? So you can figure it out. You can all take a crack at this with any of the methods you want. There's 3 of them. Choose one. Give it a shot. I'm going to do these questions in the color I did this up here. Okay? So you can do whatever you want, but I'm going to do this first one in red, and I'm going to use the red method. So I have to multiply to negative 30 and add to negative 13. And I know it's going to be S. Since that's negative, it's going to be plus and S minus. And I know it has to be plus 2 minus 15. And I know I got to divide by 3 at some point. Then I simplify. This doesn't simplify, so the 3 moves up to the front. 3s plus 2. This simplifies to negative 5. So that becomes s minus 5. Now I say to myself, self, I need to be sure I'm done. Is 3 times s 3s squared? Is 2 times negative 5 negative 10? If the front and the back are right, the middle is right. And it's done. Is everyone okay with the red method, seeing it once now without any explanation, just seeing it work through? Can you do it if you need to? It might not be your favorite, but do you feel you could do it? I'm going to do another one with the red method, and then I'll move on. I'll do 2 green and 2 blue. Is that cool with everyone? Yeah. And then you should have enough information to make your own mind up. Is that okay? All right. So I'm going to ask, would anybody like to tell me, keeping with the red method, what I should do here? 6 times 9 to get what?
54.
So I got to multiply to 54 and add to what?
21.
21. Negative 21. So what is it? I know it's going to be x minus and x minus, because I got a positive there and a negative there. So what is it? Well, it's not going to be 1 and 54. It's not going to be 2 and 27. Is it 3 and 18? Will 3 and 18 make 21 in any way? It will, right? Negative 3 and negative 18. Now, what do I got to do? What did I do with this 6? I multiplied it. Have I dealt with it yet? No, because I haven't divided it. So now I divide, then I simplify. 1/2, 3. Denominator moves to the front, 2x minus 1, x minus 3. And then I check. This is not this, is it? Is it? Except what did we forget? Say it louder. I didn't GCF. Why should you have GCF? Because the first thing I did said, what should we do first here? And all you guys said, do 6 times 9. That's okay, except what? What's the first thing we're always supposed to try? GCF. Everybody forgot that. Unless you remembered it and just didn't want to say it out loud. Are you with me? So what should I have done there first? Taken out what? A 3. What's your hint? Why was this difficult to do? I needed factors of 54 that added to 21. That's beyond the 12 times table, isn't it? You all know the 12's time table, don't you? Up to there. That's where, for some reason, we stopped there in grade 3, right? It's absolutely important you know the up to the 12 times table. Mrs. Badcrumble, what happens if it's 13? Nothing! Right? Like, for some strange reason, it always ends at 12. I don't know why. Right? You guys all had that in grade 3. So, that's a big hint. If you got to go beyond the 12 times table, you probably should go back and have a look at the GCF. Everybody cool? So, if I GCF this, what do I really get?
3.
I'm going to take out a 3, yes?
Yeah.
And that's going to leave me with 2x squared minus 7x plus 3, yes? Now look here. 2x times x is 2x squared, right?
Yep.
Negative 1 times negative 3 is positive 3, right? So this is this. What do I need to do with that 3? Just move it down to the front because I took it out at the beginning. Is everyone okay? The reason I put this question here is because everybody says, do 6 times 9. And the point of it is, what are you not allowed to forget? Everything we've done before. Like all the way back to Mrs. Badcrumble. You got to remember your times tables, right? You can't forget what we already know. So now that I've tried to trick you, and I was a bit of a dink, I apologize. Do you want to do this one with the red method? Okay. I'll give you a fair break. Is that GCFable? No. So can we go straight to 8 times 5?
Yes.
Yeah. So I need to multiply to what?
40.
What kind of 40?
Negative.
Negative 40 and add to what?
18. Negative 18.
Negative 18. What is it? 2 and 20. That's negative, so it must be plus 2 minus 20. Agreed? Now, I've rocked the 8 all the way out to here. Have I done any dividing? So now I got to divide to deal with that 8. Divide by 8, divide by 8. Simplify. What does 2 eighths become?
1/4.
1/4. Where does that denominator go?
In the front.
Into the front. 4p plus 1. What does 20 over 8 become?
2.5.
5
Oh.
over 2, right?
Yeah.
Where does the denominator go?
In the front.
To the front. And then I check. 4 times 2, is that 8?
Yes.
1 times negative 5, is that negative 5? And I've got it. Are we feeling comfortable? Now, guys, you need to be honest with me. I don't care what method you use, but like I say, I find the red method to be the most useful to my students because they're used to doing that construction from the other kind of factoring. Do you know what I'm saying? It's harder to do because you have to take some leaps of faith, right? You had to believe me. If I didn't show you this, you would have had to believe me that it worked, right? And some of you don't like that. Some of you don't dig just, and you shouldn't. When somebody says to you, this is the way it is, you should say, are you sure? And then if it really is that way, they'll show you. Do you understand what I'm saying? Is everyone okay? All right. So I am at a point now where in my perfect world, I would choose one of these and I would stick with it all the way through. But I don't want to force that choice on you guys. I want you to do your work how you, in a method that works for you. Okay? So I'm going to ask that you try to do 5, 6, 7, and 8 before the bell rings to make sure you're doing it right. And then for your homework tonight, I'm going to ask that we've skipped page 17 and 18. Yeah? Ooh, someone's getting a text. Interesting that it sounded like it was from over there, which is the girl side of the room, and that was the Old Spice thing, which is usually reserved for men, but whatever.
Isn't that the Fruit Loops thing?
No, that's Old Spice. Yeah, it's Old Spice.
I thought that was Fruit Loops.
It's a dude thing. Anyway, as I was saying, I would really like it if all the blank pages were done, but I'm guaranteeing that this is going to cause you some trouble.
Yes.
So that is optional. I will be going over that tomorrow. But the rest of the factoring pages should be done. Right now, try and do 5, 6, 7, 8 before you leave. I'll put the right answers up right now. You can see if you've been doing it right. Choose the method you want, red, green, or blue. I don't care which one, okay? Yo, go.
We're going blue. Mr. Ryan.
Yeah, I heard. I'm fixing it. Okay. I assume that some people have tried at least one of them. Please notice I just used the red method because it's the one I've been practicing the most lately in my life, so that's the one I'm most comfortable with. Again, remind yourselves of a couple of things. Order doesn't matter. This could also be 2h plus 3 over here, like these could be reversed. Okay? And like I say, it looks like I'm favoring the red method, But that's only because in my experience, most of the kids that I teach start coming around and they all start using the red method, except for a couple of them. Okay? So you just make your mind up. Is everyone all right with that? Now, I don't want to rush you through this because really, there isn't a lot to factoring, right? Like there's only 4 methods to use. GCF, trinomial, difference of squares, and trinomial with a leading coefficient. You only had to learn 4 things. And 2 of them are pretty closely related. Even 3 of them, because really difference of squares is a trinomial with a 0 in the middle, right? So really, we only learn 1 new thing. But the problem is, it's got an infinite amount of ways to apply it. Do you understand what I'm saying? Like all of you are plenty cool with, with x squared minus 9 being x plus 3, x minus 3. You're all perfectly cool with that, right? But as soon as it gets weird, it's the same rules, but it's different, right? Like if this was x squared, y squared, z squared minus p squared, q squared, r squared. Ugh. But it's the same thing, yeah? The problem with factoring is its infinite applicability, not the methods with which you use to factor. Is everybody okay with that? And the other problem is these expressions can get really, really big. But you can always factor them by following the same rules. Okay? So I don't want to rush this, even though I have done a significant amount of rushing. I've not given you any textbook work. I've kept it all the worksheets. I'm relying a lot on the fact that you guys, even though you may not feel it, you guys are actually quite brilliant. You're a very good class. Because you guys are facing, quite honestly, the hardest Math 10 I have ever taught. Because of the new curriculum and the fact that we have IB here. And every single one of you is handling it very well. Some obviously better than others, but let's be honest. Everything in the world is that way, right? Like, some of you just aren't as gorgeous as me. It's okay, right? You're still gorgeous. You're just not this. Kind of meant to stop recording before I did that gag. Shut up, Danielle! Anyways, but honestly, I do want you all to be, like, I've just been going through your cumulative exam, and I'm really happy with most of your work. Not many of you are perfect on everything, but you're doing well. And I want you to know that I notice it. And even if you don't feel that way, it is certainly the case.